Hello friend, hope you are doing well, and in this video we'll discuss about this beautiful diagram. I know you people are loving my videos and you will love this image also, and this is very funny image, but this is having a lot of knowledge, and if we will discuss one by one it will be very easy to identify the concept of the wing and center tanks. So we'll not go in more detail, but we'll discuss in 80-20-8 fueling system in more detail about all the construction of the wing and center tanks. Here we'll see one by one. I told you in last video how aircraft is taking the fuel into the kg. Okay, because the fuel bowser always still giving the fuel into the liter, and we are accepting in the kg because our computer is taking in the kg. If we talk about old aircraft, they used to, there is a computer called Candesicon, that is Candesicon computer, which is inside of the wing, center tank, all the area where that will calculate into the kg. But all the now new flight, you can say new aircraft, all are having dual com, ultra com computers. Now if you see why there is ultra com and dual com, different word used in the fuel tank computers for converting in kg. So I just wanted to see, just this is your left tank. I am just giving example. This is your left tank, this is your center tank, this is your right tank. Where the fuel bowser is connected. Fuel bowser is connected on the right side. So once you are doing fueling, traveling of the fuel to the left tank, it will be taking longer time. So that's why this computer is having advanced, you can say advanced part number. That's why it's written some different name, the dual com. So dual com will calculate the fuel depend on the velocity and speed and sound, and this will detect, and that will calculate the fuel into the kg. And ultra com also same purpose, but this is near to the fueling point. So that's why they are using ultra com. So if you go talk about the center tank, we'll go in the center tank, go inside. Okay, it is very beautiful. I have just done for my knowledge because I have given B1 assessment. So always handwritten, you can remember the thing. So 5 probe in the center tank for the fuel quantity. This is for new aircraft I am discussing. 5 probe in the center tank for the fuel quantity indication, and you will find out in center tank transfer valve, refueler valve, and cross feed valve. Also, if you go in wheel well area, all the component will be available. Then pressure switch, AP pressure switch, AP pump also will be there in the wheel well area. After looking forward valve of the center tank area. So here there is a transfer valve also. Transfer valve is working on the Venturi principle. We'll discuss in another video about the Venturi, how the transfer valve is working. Here just I am making Venturi system, how the fuel is getting transferred. So if you see, fuel is going in the inner area. And if you talk in the left wing and right wing, will be concept will be same. So I just drawn, I am not using left wing, I am just taking example of right wing. So if you see, there is a rib 1, rib 2. So rib 1 and rib 2 is a one compartment, and if you go to till rib 5, that will come wing inner cell or inner tank, basically word used for 320 inner cell, and from rib 15 to rib 22 is the outer cell, and up to the rib 26 it will come on the your surge tank. And 27 rib is the last rib of the wing. There you will get circlet, where circlet is installed. So this is all about the rib. If we talk about the engine, engine is mounted on the rib 7.8 near to 7A rib area. So engine mounting, here you will find out the LP wall and what all the things you can see. If you talk in the outer surge tank, total 90 kg fuel will come into the surge tank, but there is no indication on the ECOM for the surge tank, but you will get inner cell indication and outer cell indication on the ECOM fuel HD page. This surge tank, once fuel will come in this area, then overflow sensor or some overpressure disc and NACA. There is a 3 component in that. So overpressure disc can rupture depending on the condition, and NACA is a flame arrestor, just giving positive pressure into the tank. That's why you see NACA port is having different design under the wing. Already I have put video on my YouTube channel, and this is your overflow sensor. In case there is a overflow, then you will get decom warning, and there is a maybe MEL procedure also there for overflow. I have changed this sensor long back. So this is just for information about the surge tank. And if you go in the wing outer area, outer cell, you will get refueler valve, and refueler valve will fill the outer cell first, not inner cell. It will fill the outer cell first, and from there is a spill pipe. From there outer cell fuel will go. Once this outer cell is full, around 650 670 kg will come, then through speed pipe it will fill the inner cell. So this is all about how the fuel is getting transferred. Same will be for the left wing and center tank. And here also, if you see, there is a lot of fuel level sensor with temperature sensor. So if you there is a total 14 probe in the wing. One week there is a 14 probe for fuel level sensing and giving indication on the ECOM. I have just drawn like this: 1 2 3 4 5 6, total 12, total 14 probe on the wing. So out of 14, 12 fuel level sensor will be on the inner tank. So total it will calculate out of average value it will take from the fuel level sensing. Okay, so the total 12 probe on the inner cell, and outer cell it will be around two on the outer cell. Fuel level sensing will be there, and there is a temperature sensor. Number 2 will have, number 2 and 13 will have temperature sensor, which will give indication on the fuel SD page about the wing, inner cell and outer tail temperature sensor. So just remember, number 2 and number 13 on the outer cell, you will have fuel level, temperature sensor on the wing, which will give indication on the econ. So this is all about the probe. And here you can see I have drawn something like this. This is your black wall. This also will go in detail in the fuel ATA chapter. So clap wall, what is the purpose? Why it is installed on the rib 2? This is very good question, and this is very interesting. Why it is on rib 2? That is here also not only one. It is around 7, 3 plus 3, 6, 7. Total 7 clack wall is there. Why this is there? You will see there is a tank, wing tank. Okay, so there is a 2 pump, pump 1 and pump 2. So this pump 1 and pump 2 will come between the rib 1 and rib 2, and here you will get pressure switch also. You can see from the landing gear area there is a 2 pressure switch behind the wing area. So this 2 pump, once suppose just for example, once you are on ground, everything is good, fuel is going perfectly, aircraft is running, AP is running, if you are giving engine setup also good, because you are unstable on the ground. But once your aircraft is flying condition and aircraft is banking, what happens? This clack wall will close, and this will prevent the fuel go out of this wing area to other area, means this outer inner cell. So once the aircraft is banking, so pump will have in that compartment between the rib 1 and rib 2, there is a sufficient fuel to supply the engine, positive flow to the engine. So that's why this clack wall is there. This is very useful and this is very important. So this will prevent the pump for dry running, and there will be in-flight shutdown chance also will be there if there is no fuel in this area. That's why multiple valve is there. If one will is stuck, other will take care. Fail-safe protection. And this we have covered. And overpressure disc. We'll talk about the overpressure disc. How many overpressure discs are there? So you'll see there is a center tank also, overpressure disc on the right wing area. Then this is not visual. This is also not visual from the ground. This overpressure disc will be between the inner and outer cell rib area, rib 15, and there is one more overpressure disc you can see on the below the wing, that is for outer cell, and one you will see on the overpressure disc on the surge tank. So total from the ground you can see only 2 overpressure discs, one on the surge tank, one on the outer cell, and same will be 2 will be on the right wing. So total you can see 4. This you cannot see. Okay, there is a lot of ambient condition. You have to go through the ambient. We'll discuss later about the ambient, and center tank also you cannot see. So this is all about the overpressure. So pressure switch also we have covered. Here also you got pressure switch, and transfer valve we'll discuss later, and we have covered this also. Now the very important thing what I wanted to tell, why this image come into the picture. I discussed a lot of things. There is a transfer valve also from inner cell to outer cell, to transfer valve also there. But the main thing I brought this image for you guys because I want to discuss this thing: high level sensor, tank fuel sensor, underflow sensor. So this is very important. I want to discuss this 3 point, and I don't want to draw again same diagram. So if you see, there is a high level sensor. I am not talking about the quantity, just for example, high level sensor. If you see on the fuel, if you go on the fuel panel, there is a high level light. So there is a sensor. Once fuel will reach on the toppest portion, then you will get high level light on the fuel, where you get there on the fuel panel. And there is a tank full sensor. Once tank will full, sensor will detect tank is full. there is an underfold sensor. That is very important. Underfold sensor, what is the purpose of this in new aircraft? If we talk about new aircraft, or just for center tank logic, you can say, between the tank full sensor and under full sensor, you will see there is a 500 difference. I have mentioned just for my notes, just for memory. So once this difference will come below the underflow sensor, then only this transfer valve will automatically start transferring the fuel to the outer cell from the center tank. That's why this sensor, underfull sensor. For this only I have present this image for you guys. So once it will go, 500 differences will be there, automatically transfer valve will start working. And there is a one more low level sensor also. Once it will be around 750 kg, then you will get low level warning also. And there is a water drain valve also, multiple. I just for example, one will be on the near to the pump area. And what is need to discuss? So, and here also there will be the small jet pump, and this will take motive flow from the pump, and that jet pump will remove the fuel, and it will drop from the surge tank, and it will drop into this outer cell. So this is all about the center tank, and the center tank vent is always on the left wing side. If you see on the left wing near to the NACA area, there is a placarding. Always be precaution. There will be a chance of hypoxia because you are removing the nitrogen entry oxygen from the center tank. So if you are removing the low oxygen from the center tank because of inert gas system concept and center tank venting system, so there may be chance of, because in center tank inert gas generation system also there, so there will be the nitrogen inside of the center tank. There will be the quantity of oxygen will be below the 21%. It is I think less than 50% once inert gas generation into the picture. So what happened if below the means nitrogen in rich air is there, so that's why that placarding on there on the left side of the wing bottom area near to the NACA. Just once you are going to visit the aircraft, you will check physically, you will know it is not available on the right wing. You'll find out the left wing. That's why it is suggesting you be careful if you have related to breathing issue. Carry the oxygen better. Just for example. So my intention is that placarding, something is there in the aircraft, some hole, something indication, some placarding, everything is having purpose. Try to learn that what is the purpose of that. So that's why this beautiful image I brought into the picture. So because of that, that placarding is there. So this is all about wing and center tank. We'll discuss in 8828 in detail, and that will be so beautiful. I will use colorful diagram. I have to manage my things also. That's why sometimes it is taking longer time to present some video. And guys, hope you love this video. And if you really love this video, please don't forget to like, share, subscribe for getting more video on Airbus 320 family.